Welcome to Continental Hydraulics Introduction to Proportional Valve Products. Today we will try to cover why are these types of products available, what products and options are available, where would these various options be used, and can we compete in today's marketplace. Today more than ever our clients are asking us for help for them to increase their productivity, precision, automation, and also to reduce costs. In order to achieve these goals, you must get very clear information and factual data. What is the desired end result? You must define the specifications and the scope of the project. Example, what's the cycle time? Repeatability target, positional targets, the controls to be used, and who will be taking on that responsibility. Will multiple suppliers be involved? If so, you will need to work close with each of them if we are to get this job completed. Know the load. Will the load be the same and react the same each and every time, or will it vary? What are the ambient conditions? Mechanical stiffnesses? Is this an all-new system, or must you use existing system components and make it function better? The bottom line, proportional electrohydraulics is a system, not a component. So what do we bring to the table? We bring control. The use of proportional valves in a circuit allows you to accurately gain hydraulic variable control over a load. Once you have the control over the load, now you can make it do pretty much whatever you want, move faster and more accurately. But to gain this control, some things must also be sacrificed and then addressed. Example, normal hydraulics pressure drops are typically designed out and are not desired. Conversely, in a proportional hydraulic circuit, pressure drops are incorporated to give the hydraulic stiffness we need for control. More and better filtration. Cooling may be required. Response times of the system also becomes very critical in meeting flow and pressure requirements. You may need to add an accumulator, as the pump response time may take longer than the time available to make the complete requested move. Continental Hydraulics offers proportional valve products ranging from directional controls, flow controls, pressure controls, hazardous location rated proportional valves. We offer directional and flow controls with nominal flows from 1/4 gallon a minute to valves rated up to 265 gallons per minute. And we also offer proportional pressure controls ranging from about 20 psi to 5,000 psi. Today we don't have time to go over every size and every component. Instead, I will try to focus on the types of controls and performance levels that are available throughout our product lines. As shown here, we will review what is available by looking at the VED03 size family of products. Here they are laid out in various options and levels of performance. M&G series. They are referred to as open loop components, meaning that when a command is given, there is no device or signal that confirms it did exactly what it was requested or how well it followed the command signal. In many applications, this is all that may be required. The benefit of this would be the most economical and robust control, and they can also be used in a closed loop system where high accuracies are not required. The J, K, and X series use internal closed loop, or an LVDT, linear variable differential transducer. When a command signal is applied, the output or spool position is fed back and compared by the controller. Any deviation is then corrected, resulting in very precise, consistent, and repeatable output of the spool position. The benefit, repeatability, and consistent accurate performance. These are the types of valves that should be used in a closed loop system. These valves are not the system. They do not know if the function was performed as requested. They may work great, but even the best valves out there aren't smart enough to even know if the hose has been connected. For this, you need a closed outer loop. A closed outer loop will have a device that will provide a feedback signal from the actual work being controlled. Position, force, velocity, pressure, load. These signals are used by the motion controllers that will then compare the desired result to the actual result. Any errors then are corrected and a new signal is sent out to the valve to make these corrections. M and G series valves. M and Gs are the most economical family of products and are widely used to gain control over the motion of any hydraulic load. Many of the applications do not require a high level of precise control, only control that allows for smooth acceleration and deceleration or variable velocity. The M valves are the most flexible. The advantages of an M valve is it's the most economical. The valve and the controls are separate. No need to replace both components if one of them fails. The most robust in a high temperature or tough ambient condition. Reprogramming the controls is also quick and easy and can be changed on the fly. No special programming box is required. The disadvantages: the control card will require panel space, and you must manually program the motion control card the first time. The main difference between an M and a G series valve is the G series incorporates onboard electronics, or OBE. The advantages of OBE: no panel space is required to mount a separate module to control the valve. Plug and play or plug in and go. This means that they are factory pre-programmed to optimal performance and repeatable performance to the catalog specification. This gives you valve-to-valve interchangeability. The disadvantages of an OBE: the valve and controls are one package, not individual components. If the valve gets worn out or contaminants damage the valve, you must replace both the valve and the electronics. If the electronics get damaged from a power surge or a short, you must replace both the electronics and valve. This is very costly at times from the user standpoint. Reprogramming also takes a little bit of work and a programming box. Note, if you do reprogram onboard valves, you can lose the valve-to-valve interchangeability. As you're looking at the slide, you're seeing several other options here. We will circle back to the GL, MG, and GH options in just a minute. The J series valves are similar to the G series, and the advantages and disadvantages are also the same. However, the J series also incorporates the use of an LVDT spool position feedback for the control. The LVDT is mechanically connected to the spool and provides a signal related to the spool movement. The onboard controller with this feedback signal then has total control over the spool position. Example: if you ask the spool to move 50% open and the spool for any reason only moves to 49%, this error will be amplified and the coil will receive more amperage or force to get it to the 50% demanded spot, resulted with higher accuracies and repeatability. Valves with total control over the spool position are also much faster. Unlike an M or a G series type valves, they are programmed so that at maximum command signal, this generates a capped amperage going to the coil for the 100% shift. This capped amperage limits the coil's maximum linear force, or the electromechanical force that pushes the spool against the spring until the spring force and the coil force are equal in value. And that's where the spool stops. Because we are controlling the spool position and not the maximum amperage, we can then send higher power levels to the coil for more force to push the spool to the desired position faster. Conversely, when we want to come back towards the center position, not only do we drop the coil to drop out the power to the coil, but now we can also, because of the closed loop and the error between where the spool is, what actually happens is additionally we power up the opposite coil. This results in faster response of the spring force now plus the coil force pushing it back to center. Okay, now back to the L, the G, and the H, or the MG or MJ. The L, economical performance. Although the L option valves use a low profile, very compact electric box, there is no reduction in the G or J series catalog performance specifications. Due to changes in various components like the M12 5-pin connector and the physical box as compared to the standard series valves, the valve cost or initial investment is reduced, making these valves the perfect choice in any competitive situation. From the machine builders' desire to reduce costs, they can reduce costs in two ways. One, the valve itself costs less. Two, the cost to wire the valve. An M12 5-pin cords are much more economical than the traditional 7-pin cord assemblies. But wait, there is more. The new design electronics also allows for additional ways to control and connect to the valve. The standard uses an analog input, plus or minus 10 or 4 to 20 milliamp. This option also brings in a digital control, making it very easy to implement. Here you can get the I/O link communication protocol, or you can get CAN open communication. These new control options put you kind of in the driver's seat, as most of our competitors don't offer controls like this. Here is the standard valve. This is the MG or the MJ. It uses a standard 7-pin common everyday connection. The standard G and J shown here are the current standard that numerous manufacturers have used for many years, and they incorporate the MIL-C 5015 7-pin connector. These valves are interchangeable with all the competitors in their classes. The performance specifications all the way to the pin connections allow for interchangeability with most all valves in the marketplace today. It's the standard. We also now offer what we call the H series. This new series of valves from Continental Hydraulics are compatible with various Fieldbus communication types. Ethernet IP, Profibus DP, Profinet, EtherCAT, CAN open, PowerLink. Also available are input connections for analog or digital transducers. Now, based on your customer's preferred communication protocols that they use, you can now offer Continental valves as an alternative to anyone's products that they currently use. The next two product groups that we will be reviewing are used in applications that require higher levels of performance and control. When the application requires high-speed moves and precise control over position or force, the valve reaction time and the ability to accurately follow slight command signal changes becomes very critical. Although the J series valves are very good and rated up to about 45 Hz operation, they may not be good enough. Generally, any manufacturer's valve similar to our J series will be very close in the overall performance specifications. So for high performance applications, they must jump to the next level, which is a spool and sleeve type design or a high-end servo valve to meet these requirements. Yes, we can do that as well. But before we take that jump, let's take a small step here. Continental also offers a very unique option, the VED03 K series valve. This is still a spool and body design, making it very economical and can still provide the high response. Thanks to improved electronics, advanced algorithms, the response of the K valve is rated up to about 100 Hertz operation. Yes, you heard that correct. Twice as fast or twice as many corrections, this equals higher accuracy of the control. The best part about this valve is once applied, whether performance is truly needed or not, you really no longer have any competitor that can compete. Like everyone does when they see an applied product, they go to the catalogs and review the performance specifications. Then they cross over the performance data over to what they can offer. In this case, they will need to jump up the sell price to their spool and sleeve type design valves to meet the performance specification. Thank goodness, most of the time people only seem to ask the true details when they're first doing a machine design and not when they're trying to cross something over. The X series. The X series valves are our highest performance products that we offer today. We have a direct operated D03 and D05, high-speed servo performance spool and sleeve valve design, fail-safe spring offset or 4-position design. As shown here, the D03X valve has a step response time down to 8 milliseconds, 160 Hertz operation at 90-degree phase lag, plus or minus 5% signal. Pilot operated versions are high-speed servo proportional pilot valve, spool and sleeve. They utilize a dual feedback, one on the pilot valve and one on the main stage. Zero lap spools. Step response times are down to 14 milliseconds. 100 Hertz at 90-degree phase lag, plus or minus 5% signal. Also available in these valves, we do offer the traditional 7-pin analog command type signals, and we also now offer them with the various Fieldbus control options as we discussed earlier. Okay, throughout this introduction, I've referenced a couple of different designs. The first one is the spool in body, is just that. Production-made spool in a production-made body. Although spools are made today with high precision, there is still some tolerance variances between one batch of spools to the next. Production-made bodies also have tolerance variances due to small internal core shifts. Standard valves also use centering springs and centering washers that could also have some variations. The spool and body type valves also use two different solenoids, one for each direction. So moving from a flowing in one direction to the other, one coil is powered down, then the other needs to be powered up. Complicating this is when you're powering up a coil, not only do you need to overcome the initial spring load that centers the spool, but also move the spool through a deadband region to get to the point where it can start cracking flow. Valves like the J and K series, because of the way the electronics control the movement of the spool, moving through this region is quick but still present. Generically, the J series with the transition through this region is about 10 to 12 milliseconds of time. This step tends to drive high-speed motion controllers a little crazy. They don't like that step. The K series, though, with the improved electronics, going through this transitional region is about 4 milliseconds, typically fast enough that high-speed controllers can deal with it. Spool and sleeve designs are much higher in precision of the internal parts. The variance of the body casting and other mechanical parts are eliminated due to the sleeve. A spool sleeve valve can also uses a single solenoid for the complete movement of the spool against an offset spring. The fail-safe position is a fully spring offset condition when powered down. The powered on valve center condition means that the solenoid is basically receiving 50% amperage. So when responding to a command signal for a movement, there is no time delay, as the coil is only reacting to an increase or decrease in power. Also shown here, we have Bode plots that our industry uses to rate a valve. When looking at catalog data, you will see reference of valves rated frequency at plus or minus some command signal percentage. Our industry uses the -3 dB and the 90-degree phase lag points to rate these valves. This is basically worthless data. Phase lags are additive. In a hydraulic control system, there are many things that will cause phase lag. Response times of various components, compressibility of fluids and lines, mechanical stiffness, backlash. In a typical cylinder positioning system, our hydraulics and mechanical add up to about 90% phase lag. So when we try to incorporate and run a valve at its 90-degree point, well, I think the motion controller may have a hard time becoming stable. Again, they are additive. When estimating what type of system performance can really be achieved, or the real world, start looking at how many hertz a selected valve in reality can do at the 30 or 45 degree phase lag points. These are also key points to really look at when comparing the performance of one valve manufacturer to another. You will see a big difference. Controls. We better talk about a few of those because we have talked about the M valves and also closed loop systems. Continental Hydraulics offers several DIN rail mounted modules. The first one is the most common, the CEM module. It is for running an M valve. It has an analog input resolution of about 0.01%. The communication is done through a standard USB Type B connection. In the AA card, you do have 3 selectable modes of operation. The AA mode, same as the current AA modules that you've been using. It looks for a plus or minus 10 volt, a 0 to 10. You can scale those inputs, 4 to 20 milliamps. It's your standard base amplifier. The second mode is what we call the AB mode. This gives you the ability to run 2 separate coils with 2 separate command signals at the same time. The third option here is what we call the RA mode. It uses digital or on-off signals, and you program the speeds and the ramp times accordingly. The CEM PA card for pressure or velocity control type applications, it is a closed loop card. It has an analog input resolution of about 0.006% on both the command and the feedback. Again, the communication is done through the USB Type B connection. There are some added features. Improved integrator control function parameters, allows for tuning of a high loop gain application, and allows for less overshoot and stability near the 0 error set point. We also offer closed loop position controls. The CEM SA or SD analog input resolution of about 0.003%. The analog output resolution is 0.006%. The SD module is used for feedback devices that utilize SSI type signals. Again, the communication is the standard USB Type B. The output signal from this card is plus or minus 10 or 4 to 20 milliamps. It is a position controller. There are some added features here as well. We have added filters to improve the dampening rates and allow for higher loop gains required by the high-speed applications, especially if you're going to be using the new K or X series valves. There is drift compensation for highly accurate positioning, allows fine-tuning near the 0 when the typical high loop gains would cause instability. We also offer closed loop synchronization modules. We have two different styles. One is referred to as your standard master-slave type setup, where one will follow the other and they cross-talk, cross-communicate to look at the synchronization. And we also have one that we call the bypass synchronization. That is used in systems that will use something like a gear type flow divider. A flow divider traditionally is 95–90% efficient. So that means there is 5–10% of the flow that's actually out of control. Therefore, you're not going to get good synchronization. That particular card, the analog feedback devices, each go into this card, and the error between those two tell a small valve to either add flow or subtract flow. Actually, it adds and subtracts flow at the same time, synchronizing, making it a very economical type system. So we do have some unique products there as well. So with all the performance level and control options that are available, yeah, I think we can compete competitively in any marketplace today. Please visit our website to see all of these products as well as see all the other products that are available. I hope this brief introduction gives you a better idea of what types of control and performance we can deliver. Please let us know if we can help you to design solutions and solve your applicational requirements. Thanks for listening in.